Take a look at 12.6 question 2. It's got the square in there, so for this one it doesn't look like you were able maybe to get a good start on this. So we're given a consumer price function. Here, so this is our function. And what we're first asked to is determine the price elasticity of demand when the price is set at $30. So we know that P is 30. And we want to calculate the price elasticity of demands. And we're going to go to 3 decimal places. So let me change color here. So for price elasticity of demand, we have minus the function value derivative times the price over the function itself. So the derivative, that might be where the issue is, finding the derivative. Again, what I'm referring to as f of p is q. You could use those interchangeably. So the derivative of f of p, let's go ahead and now you could either square this out to get a quadratic and then take the derivative, or let's give it a try using the chain rule to see if that makes it easier. So the chain rule says take this, take the outside function, which would be the 2 comes down in front. Nothing happens to the inside function, and then now this is to the first power. Then we take the derivative of the inside function, which is just going to be minus 1, and we multiply by that. So this is our derivative. So you could rewrite that as minus 2, negative 1 times 2, 94 minus p. So this is the derivative function. You can distribute the negative 2 through if you would like. That'll give us, it's 180 plus 8, so that's negative 188. Negative 2 times the negative 1 gives us a positive 2p. So this is our derivative. And then we're going to put it into this formula up here to get the elasticity function. E is equal to minus negative 188 plus 2p times p all over the original function, which is 94 minus p squared. Okay, so we can take this part in the front, multiply it times p, so we get, or you could just plug in the 30 at this point if you want, but we're probably going to need this in a little nicer form for this question B, where we have to find, we have to set E equal to 1 and go from there. So we'll multiply this part, distribute the P and the negative. So this negative is going to make that a positive, this negative makes that a negative. So we get 188 P, so positive from here, the P comes over, and then this is going to become negative 2P squared, because P times P is P squared. all over 94 minus P quantity squared. First part of the question is, let's see what this is equal to when P equals 30. Okay, so we've got our elasticity of demand function. So we've got 188, 30 minus 2, 30 squared, all over 94 minus 30 squared. Okay, so a little bit of calculator help here. So 188 times 30 that's 5640. From that we're going to subtract, do a parentheses, and do 30 squared times 2, close the parentheses, hit the equals, so that should give us in the top, if you'll see this, 3,840. Let's go ahead and record that as we go. $3,840. And then now just calculate the bottom. 94 minus 30 is 64. 64 squared is all we need to calculate. So I'm going to clear that out. 64 squared is 4,096. I don't know why sometimes this pen doesn't want to write, but here we go, 4,096. So we do our math here, 3,840 divided by 4,096 gives us 0.9. 0.9375. They want it to 3 decimal places. So let's go ahead and do that. 0.938. So that's what that means is we actually want to sell it at a higher price, right? Because it's less than 1. So this is what's called inelasticity. The value is less than 1, so it's not going to make much change in the revenue by moving the price up. So let's move the price up, and we should gain more revenue. Okay, so that's that first part. While we're at it, let's just go ahead and let's check this out. Let's go submit it just to make sure the first part's right. I mean, you probably do that, right? Found that out last time. Let's see. Here we are. Yeah, we got it correct. So that's good news. Interpret the answer. So the demand is going, let's see, when it's inelastic, the by blank something per 1% increase. So it's actually going down by 0.1%. 0.938% for each 1% increase in price. So I increase the price by 1. The demand only goes down. It goes down less than 1%. So that's the good news. So I guess we could check that one again. But I just want to keep going on this one just in case, you know. So we can check it that way. Yes, it is going down by that. That's what that means. So then what price should maximize? We're going to set this equal to 1 and then solve for P. Okay, and then once you have that, this one's a little bit quicker. Once you have your price, you plug that into the original function, the original equation up here. So you take that price, plug it in here, and that will give you the demand. Approximately how many cases? That will give you the cases of tissues once you get the P. So I'm going to allow you to go through that. Let me just get you a quick setup here at what price. What we need to do, get the calculator out of the way, is what you need to do on this one is start here, set this equal, set it equal to 1, and then solve for P. Remember, you can cross multiply, probably FOIL this out. Your P squares are going to somehow cancel. You'll get that down. You might get a quadratic. You can solve it with quadratic means. But let's see how that goes. If you still have questions, post it in the discussion forum, and either Travis or I will get back with you. Okay. Then once you've got this value, you'll solve for P, the best price. Then you plug the P right up into here. Subtract 94 from P, 94 minus P, square it, and you'll have your number of cases of tissue. All right. Thanks.